In this example, we're asked to find the general term for each sequence. If we take a look at the first one here, I can recognize that these are some numbers that are being squared. So the first thing you got to do is you got to figure out, what's happening. Are these cube numbers? Is this a factorial? Are these just fractions? What is the link between these different numbers here? And so one of the tricks that you can do if you can't see the pattern, the actual general term right away, would be just to rewrite them. If you can tell, that they're being squared, is just to rewrite them actually as those values that are being squared. So you can see here in this series that each term looks like there's a pattern between the terms and they're all being squared. So I know my general term is going to have a squared part to it. And then 4, 7, 10, and 13, if we look just at those, that's an arithmetic sequence. And so we could rewrite this as 3n plus 1. And let me rewrite this a little bit better for you. So this is 3n plus 1 quantity squared. If we pick the third term, 3 times 3 is 9 plus 1 is 10, and 10 squared is definitely 100. So this does work for the general term. Now this next one I wrestled with for about 5, maybe 6 minutes, something like that. So what you're getting here is my thought process in about probably maybe a minute here, but it took me a little while. So if you can't see the pattern right away, don't worry, just keep trying. Oftentimes if you give it your best shot and don't give up, you can actually get these. So this 5 here, for me, I saw that was 4 plus 1. And then this 6 here is 4 plus 2. And then the next one, this 8, is going to be 4 plus 4, and so on and so forth. So I know the thing that's staying the same is the 4. What's changing is we're adding a power of 2 every single time. So I'm going to write 2, and then I had to write n minus 1 in this case. The reason why is that n is 1 for the first term, and I only want to add 1. I don't want to add 2. So 1 minus 1 is 0, and 2 to the 0 power is definitely 1, plus 4 is 5. Does it work for the fifth term? I hope it does. The fifth term, where n is 5, that would be, let's see here, 4 plus 2 to the 5 minus 1, or 4 plus 2 to the 4th, and 2 to the 4th is 16, so that's 20. So it does check out. So I'll rewrite this for you and make it a little bit nicer. Just 2 to the 4 plus 2 to the n minus 1 power. So just try to see if you can find a pattern between the numbers, and oftentimes that will lead you to the correct result.